Hello friends, let's try this question. This question is from the set. Question says let A be set of n that belongs to set of natural numbers such that n is a 3-digit number, B is set of 9k plus 2 such that k belongs to set of natural numbers, and C is set of 9k plus l such that k belongs to set of natural numbers for some l, and l varies between 0 and 9. If the sum of the elements of the set A intersection of B union C is 61 into 1800, then L is greater than option 1 is 7, option 2 is 6, option 3 is 4, and option 4 is 5. This is question with more than one option correct. Let's start solving this question. So in set A, elements are natural number and all the elements are 3-digit number. So element in set A will start from 100, then we will have 101, then we will have 102, and so on up to 999. Okay, and it is given that if the sum of elements of the set A intersection of B union C is 61 into 1800, and we have to find the value of L so that we can compare its value with the given options. Now let's find the sum of elements of the set A intersection of B union C. A intersection of B union C. See, in set A we have all possible 3-digit natural number, and this set will contain common elements of set A and set B union C. So common elements will be numbers of B union C, which should be of 3-digit, right? So we can write it as B union C, and B union C must contain 3-digit number. So to have 3-digit numbers in B union C, we will take 3-digit number of set B and 3-digit number of set C. So 3-digit numbers of set B will start from 101, then we will have 110, and so on. The last 3-digit number of set B will be 992. Now let's find the sum of these numbers. So to find the sum of these numbers, first of all we have to find number of these numbers. So last number is 992. So we will apply the Tn formula of AP. Tn is equal to A plus n minus 1 into D. First term is 101 plus n minus 1 into the common difference will be 9. So we will get here 992 minus 101 is equal to n minus 1 into 9. So it is 198 divided by 9 plus 1 is equal to n. So on dividing by 9 we will have 9 plus 1 is equal to n. So we will get value of n as 100. So there are 100 3-digit numbers in set B. So sum will be sum of 3-digit numbers of set B will be n by 2. N is 100 by 2 into 2, first term plus last term. First term is 101 plus last term is 992. Okay, now let's simplify. It is going to 50 multiplied by this is 3910. So we will have multiplication as 0, That's a 15, carry 1, 45 plus 1, 46, carry 4, 4, then 5. We have 54650 is the sum of 3-digit numbers of set B. Okay, now let's find the sum of elements of set A intersection of B union C, which will be equal to sum of 3-digit numbers of set B union C. Okay, so sum of elements of A intersection of B union C is equal to sum of 3-digit numbers of B union C, and this sum will be equal to sum of 3-digit numbers of set B plus sum of 3-digit numbers of set C minus sum of 3-digit numbers of B intersection C. And we already know that sum of 3-digit numbers of set B is 54650, and remaining as it is set C minus sum of B intersection C. And it is already given that the sum of element of set A intersection of B union C is 61 into 1800, and this multiplication will give 109800. Okay, so it is 109800. Okay, now let's find the sum of 3-digit numbers of set C. So to find the sum of 3-digit numbers of set C, we have two cases depending upon value of L. When value of L is equal to 2, then set B and set C would become same, would be equal. When value of L is equal to 2, that in this case this set sum of element of set B and sum of element of set C would become equal. So we will get sum of B union C as sum of 3-digit numbers of set B, which is equal to 54650. But it is already given that the sum is 109800. So these are different, which are not equal. That means L cannot be equal to 2. Now when L is not equal to 2, so sum will be 109800 is equal to 54650 plus 3-digit numbers of set C. The element of set C is in the form of 9k plus n. So we will take the summation of these elements, summation of 9k plus n. And what can be the list value of k? So list value of k. See, the remains of this set C must be of 3-digit numbers. So the list value of k will be 11. When k is 11, that time this multiplication is 99 and L is varying from 3 to 8. Okay, so adding a minimum value of L3, we will get 3-digit number. Okay, and last value of k will be what? Last value of k will be 110. When k is equal to 110, this multiplication will give 990, and on adding the value of L, we will get the last 3-digit number of set C. Now let's simplify this. We have 109800 minus 54650 is equal to, now let's apply the property of summation of 9k. K is varying from 11 to 110 plus summation of L. Okay, so this is equal to 0, 5, 1, 4 and 5, and this is equal to 9 is taken outside of this summation, and summation of k is equal to 11 plus 12 plus, and it will go till 110, and this is equal to, see how many terms is going to be from k is equal to 11 to 110. It is going to be 100 terms, so we will have 100 into L. Okay, and let's find the summation of these terms. 9 into number of terms in this case is 100, so we will apply the formula for finding the sum of terms of AP, which is equal to n by 2 into first term plus last term. Number of terms are 100 divided by 2. First term is 11 and last element is 110, and this is equal to 100n. Dividing by 2, we will get here 50. So this is equal to 9 into 50 multiplied by, this is equal to 1 to 1 plus 100 L. This is equal to 54150. Dividing it by 10 to all the terms, we will have 5415, and now let's multiply this. 9 into 5 into 121, 9 into 5 45, 45 into 121, it is 5445 plus 10L. Then 5415 minus 5445 is equal to 10L, and this subtraction is equal to 70 is equal to 10L. So on dividing by 10, value of L is equal to 7. So we have got the value of L, which is 7. Now let's compare this value of L with the given options. We have to find such numbers which are greater than L. So we find that option 2, option 3 and option 5 are correct according to given question. So correct options are option 2, option 3 and option 4. Thank you.